Yeah, so I was saying in this program we are asked to give this kind of tutorials, at the main conferences in robotics to explain how the process of reviewing works, but in general how the system of journals and conferences work, because to young people maybe it's not very clear. There are some details. Yes, so as I said in the announcement, the slides and my talk are based on how things works in robotics, okay? Because I'm from robotics, so I will talk about how our conferences and journals work. But then, I think many points can also be translated to other communities, especially if they are within the IEEE. You see, so in general, things are not very different among IEEE journals and conferences. So yeah, I will talk about this, and then after me, there will be another talk on a recent breakthrough in robotics by Tommaso, who will explain you a very important notion. Okay, and and the slides are in English, and even the talk is in English. Okay, so just okay. So let's see. Yeah, so I can make the slides available afterwards if anyone wants them. So these are some sources that when I prepared these slides, I think 3 years ago, something like that, I looked for getting some insights. Yeah, just for information, see, I feel, let's say, that I'm gonna say entitled to talk about this stuff, also because I've been part of the editorial board of the main robotics journal, which is the IEEE Transaction Robotics, for more than 10 years, basically, because I started as editor in 2012, and then I stayed there. Now I'm a senior editor, so I've seen a lot of papers. So I have some experience in this field. And these are some sources that also of very nice papers that explain more in detail what I will say in my talk. So why reviewing? I don't know if you ever wondered why we have to do this. So it's for the community. It's called our way of doing quality control, if you think about it. So we have to decide if something is worth publishing or not, to fact checking, to everything should be falsifiable in science, and it's a necessary service to the community. So I don't know if there is another system that could be better. Maybe yes, but sometimes I discuss a lot about this stuff also when preparing these slides. It's in my opinion, like kind of democracy, in the sense it is the best worst system that you there are alternatives, but if you want to keep something, I will say democratic, in the sense that your work has to be judged by peers that are independent from you, and that's you can fine tune the details, but more or less I think it has to work like this. Okay? And it's also a service for the author. So I don't know, maybe this is something that you don't think about it a lot, but when you do review, of course, if you do it in a constructive way, you don't start insulting, the authors, then it's also a good feedback for the authors themselves, because they will learn something, they will think about something that they didn't thought about. And also for yourself, of course, because you will learn about what the other people are doing, okay? And also you can improve in how you write your papers, because you will see, hopefully at some point, good papers, maybe better papers than your papers, and then you see how the other people how they manage. Okay, so this is a possible flowchart, okay, of the typical review cycle. So at some point you get an email, in general, that invites you to review. And then you have to check these 3 boxes, I would say. So do we have the appropriate expertise? I will come on this later on. Do you have enough time? Okay, because if you commit, then you have to do it, and doing it takes some time, especially when you are young and not that experienced. And do you have conflict of interest with any of the authors? Okay, so if you don't have the expertise, don't have time, or you have a conflict of interest, then you should decline. And recall very well this word, decline quickly, because what happens many times is that people send invitations for reviews and the reviewer doesn't respond, okay? Or it responds after 1 month. Okay? But then for 1 month, the facilitator has to wait for this response and he cannot invite another reviewer. Okay? So if you have to decline, you do it quickly in 2 or 3 days. Okay? And also, it's also good practice, I would say, in general, to suggest other names. Maybe you know other people who could be good reviewers. You suggest them, and and then the board will see what to do. Otherwise, you accept. And also, when you accept quickly. Again, you don't accept after 1 month saying, yes, I forgot, I will accept, because then it's a bit too late. Then after you accept, in general, what do? You have a first read of the papers, and I mean, this comes with experience, I would say, but at some point you get experience enough, I think, to judge, quickly if the contribution is, I don't know, substantial, is very significant, the technical quality is good or not. And if it is clear that the paper is weak, because sometimes papers are quite weak, then you can propose or write, depending on how the system is set up, and editorial reject. Okay? Editorial reject is a way of basically returning the paper to the authors without a full review cycle, just with some kind of report, which you may propose, but then it is refined by the editorial board. So at the end of the day, it is not your name that appears in the report. Your name never appears. And then this report will tell the authors that your paper is too weak because of this and that, and then so it's a way of quickly giving a negative, but anyway, quick feedback to the authors, such that they can improve and move on instead of waiting for 3 or 4 months to get an answer. Otherwise, if the paper is good enough, then of course you have to read it much more thoroughly in all the details and while the review in time. So this is, again, very important. You are given a deadline. If you don't respect this deadline, then you will start introducing a delay, and then this delay will accumulate, and then the authors will get a decision later than the deadline. And then when it will be your turn, you will start wondering how come that I'm waiting since 5 months to get a review because someone is late in the process. And in general, it is, so the reviewers are the ones who are late, I would say, in most of the cases. Also, the editors or the associate editor can be late, but I would say 99% of the cases, everyone is waiting for the reviewers, so for you. So when you cannot complain if when it is your turn to wait for a review. Okay, so what is a possible template of a review? I think it is a good practice to start with your own summary of the paper. So your own summary of the paper, like writing like a second abstract, if you want. So you restate, what are the points, what is the contribution, such that your view on the paper is clear. And this also helps the authors to see if what they try to convey reached the reviewers, or reached the audience. Then you do your comments, that summarize your opinion, good, bad points. And it is very important to remember that you don't have to state in the review if you recommend the paper for acceptance or reject. You never have to say, then this paper should be accepted or this paper should be rejected. This is not up to you, it is up to the editorial board. You can say this is good, this is bad, this is weak, this is strong, but don't say explicitly what is, in your opinion, the decision on the paper. And and then a list of points, also minor details. So some points to keep in mind. You should comment about what is, in your opinion, the contribution of the paper, even if, so the answer can also be there is no contribution, but then you have to say this in a polite way. If the authors are able to explain the significance of their work in the context of the state of the art in their field, if the paper is clearly written and organized, if the introduction states well the purpose of the paper, the references are complete. So if the paper is not technically sound, in the sense, at some point there is an error in the math, then you have to state it, but you also have to explain why. You cannot just say, math is wrong point. You have to say it's wrong because of this and that in this particular equation. Okay. And if the paper is too long, you can say it, but you also have to say explicitly how it could be shortened, because it is too easy to say the paper is too long points. You have to say it is too long, and this or that could be cut. Okay? To provide some guidance. Some suggestions, some tips. This is a typical, let's say, error that in general, especially at the beginning, one can make. you have to read and review the whole paper, not just a part. So the classical example is that you start reading the introduction and the literature review, and this is not in a good state. Maybe they are missing the right references, the right positioning, and then your review is based on this. You criticize this point and nothing else, more or less. Then this is not a good message, because it will seem to the authors that this is the main problem of the paper. So in the revision, they will try to fix it, only that. But then maybe there were also other problems, so the paper maybe will get rejected. They start to get frustrated, because how come that we fixed the literature review and then the paper didn't make it? So it is important that the review touches all the points, not just one part. Okay? Then another explicit point is that, of course, the reviews are anonymous. No, I never seen a reviewer, saying this is my name. This never happened to me, okay, so far. But I've seen many times that a reviewer starts saying, yeah, you didn't, you missed, you didn't position your work in a proper way, and you missed these references. And these references, how come? They are all from this guy, or from the group, or from their group. And then it's like revealing your identity. So, I mean, this is a human thing. It's especially when the paper is in your field, it is, tempting to say, how come they didn't cite my works? Because it's normal. But you have to try to resist this urge, I would say. It's okay if you suggest some of your works, but then you have to suggest also works from other people to give a balance. So to not make it obvious that you are referencing to yourself. Now, reviews should be respectful, of course. You don't have to be harsh, unrespectful, sarcastic, yeah. Also because, I mean, keep in mind that this can happen sometimes because, I don't know, maybe you are in a bad mood or whatever. But, I mean, reviews then will go to the authors, and oftentimes maybe the first author is a student or a young researcher, and receiving very bad and sarcastic reviews is really hard. It can have a very negative effect on young people who don't have much experience or much confidence. So you be respectful, don't. And also highlight the positive points of the paper, and then you may also encourage the authors to keep on working on this topic, because you may say, you are not at a good level now, but if you improve on this and that, then I think the paper could be a good paper. Then be specific, concrete, factual in the comments. Always try as much as possible to avoid generic comments. So, for examples, you say the idea algorithm has been already been considered in many previous works. Points. This is not a good comment, because then you have to say which ones, okay? Which works, what parts of the algorithm, why you state this fact. Or the idea algorithm should be compared against alternatives. This is really common. You at some point you get a comment, you didn't compare against something else. But what something else? You have to you cannot stay generic in most of the cases. And also, when you propose a comparison, I have a slide later on, you should also consider if the comparison is feasible in the time frame which is given for the revision. Okay, the revision, for example, in transaction robotics, you have 6 months for a major revision, so the comparison should be something feasible in 6, maybe 5 months, not something like that, not something that will take 1 year, because otherwise you cannot ask it. Then, if the paper is too long, then how it could be shortened. Again, the technical content, where and why, and so forth. Oh, yes, about the comparison to the state of the art. Again, this is, I think, not an easy topic, because, of course, comparison is essential in science, so you have to compare. But this comparison, as I said, must be reasonably feasible. For example, you may ask to compare against too many different algorithms. You cannot ask a comparison against 10 alternatives, because it will take maybe too long to compare. And also, keep in mind that if you say, yes, but this other group did something similar, you didn't compare, and if the algorithm is very complicated and they didn't release the code, I mean, it is in most cases impossible to replicate exactly the code which underlies the work of another group if this algorithm is very complicated. You will never be able to have an implementation as accurate as they had, maybe because they worked on that for 2 years, in 5 months, starting from zero. So if they don't release the code, consider this fact. I mean, can you really make a comparison by re-implementing everything from scratch in your in 5 months? In most cases, I will say no. And on the other hand, related to this point is that you can always recommend or encourage the authors to make their code available online, because then this will help, of course, the reproducibility and also comparison for future papers. So other suggestions, you should, since your name is never revealed, so you don't have to fear, repercussion of because maybe you are criticizing a big name. Your name will never appear. So, and if you don't make mistakes like citing too many of your works, they will never know who you are. So your judgment shouldn't be affected by the names, the labs affiliations of big names, of big labs, but also by the technical complexity. So maybe this doesn't apply to all the fields, but in robotics, sometimes you get papers that are very, very mathematically complex, let's say, with a lot of math, a lot of theorems, and you can feel, especially when you're young, intimidated by this mathematical formalism. But then if you think about it, maybe yes, everything is beautiful, but the significance in robotics is not that big. And you should say that, even if the math is perfect and wonderful. Okay? Yes, as it is written here, you have to balance between the technical correctness and the significance of the work in robotics now for robotics, and then for other communities it will be different. And for example, in robotics, the contribution can take many forms. You can a paper can formulate a method or an algorithm that solves another problem, an open problem that improves over an existing problem. It can revisit a known problem, but from a different angle, and this revisitation brings new insights, new ideas that you didn't think about before. Or sometimes it can also propose a novel and very thorough comparison or experimental validation of different algorithms. I remember a very nice paper from Davide Scaramuzza on a comparison of MPC schemes for flying for drones. It was a very well done comparison, a very strong paper. Okay, so about the novelty, I just, this comes from a nice article on this blog. So novelty is a subjective quantity. Just keep in mind that you shouldn't trade, or let's say, should make the distinction between novelty and difficulty, in the sense that something which is new or interesting doesn't have to be necessarily complicated. A good idea can also be a simple idea if nobody thought about it before. Even if it's not a good review to say this is very new, but it's simple. But if you didn't think about it before, then it's a good idea. And also with the surprise, again, sometimes you see an idea which after you read it, it seems obvious, and then you start to decrease its value, but you didn't think about it until that moment. So they thought about it, so the idea is novel. Okay? And I have a point about usefulness. So sometimes, we get some more theoretical papers, maybe let's say the idea, your comment would be, the idea is novel, but I don't see how, anyone could use it at some point for more practical purposes. So now this can be a comment by all means. Just, I would say, when you want to make this comment, think about it 3 or 4 times, because you never know. In science, maybe at some point something will be useful. So you can make this comment, but I will just a suggestion, think about it well, and then of course you can make it. Now, in our context in robotics, there is this idea with some journals, for example, Transaction Robotics, of evolved papers. I don't know if this exists also in other communities. So where basically you can take a conference paper, then improve it by adding more stuff, and then turn it into a journal paper. This is this evolved paradigm. And what happens in these cases is that sometimes reviewers complain that the journal paper is parts of the journal paper are too similar, or even a one-to-one copy of the previous conference paper. And then basically this affects all the review, and then the review is negative because of this fact. This is not a good reason. Why? Because when journals implement this evolved paradigm, the rule is that there must be enough new material. Okay, but then if you decide that there is enough new material, the authors are completely allowed to copy paste the conference paper if the decision is there, enough material is met. Okay? And so, yeah, you cannot complain. This part is exactly like in the conference paper because it's completely allowed. It's not a comment that you can that you are allowed to make. Another suggestion is that maybe I think at the beginning one might not think about is to use the confidential comments to the editor or associate editor. You will see when you review a paper, in general, there is the box of the review and another box, another text box where you can have your own confidential comments. And these comments only go to the editor. They don't go to the authors. So here you can say whatever you want. That will not go to the authors. You can share your, more candid opinion about the paper. Sometimes you may have some issues about possible plagiarism of other works of the own author's previous works, and then but you don't want to state this to the authors because you are not sure. So you can state this in the confidential comments, and the editorial board will check. You can add additional references that you don't want to disclose in your review. So you really use this box because in this box you can give a lot of information that you don't give to the authors. Oh, then I have some, let's say, FAQs, okay? Some common questions that we got over the years with some possible answers. So let's, what time it is? Yeah, I have still time. So for example, sometimes a question that we got a lot is, should I be fully confident in the paper topics in order to review it? So it depends, because you may not be an expert, for example, you may not be an expert in the technical details if the paper is very heavy on math, but you may be an expert in the field, so you may be in a very good position to judge if the work has some impact of significance, besides the fact that it is mathematically correct. So, or sometimes some papers are interdisciplinary, they touch, I don't know, neuroscience and control, for example. Then you may be confident in one of the parts because the board, the editor decided to have one reviewer for one part and a reviewer more expert in another part. Anyway, again, if you're in doubt, you can always use the confidential comments to inform the board that, I didn't feel confident in this part, so I commented only that part. This is completely okay. Oh, then there is another problem, which, because these slides are a bit old, so now maybe it's not a problem anymore, but sometimes we get papers that are written in a barely understandable English. Maybe today with ChatGPT, the problem doesn't exist, I don't know, but when we made the slides, the problem was still existing. And what should I do? Here, I will say that if the authors are not native speakers, it is completely understandable that they will not write like Shakespeare. So, yeah, you have to accept it. But of course, if the English is so bad that it is really impossible to understand what they are saying, then no, it is a major flaw. So you cannot complain because the grammar is not perfect, but you can complain because it's completely not understandable. Yeah, then it is a major flaw, and a paper can be completely rejected because of this fact. How much time should I invest in a review? It depends. It depends on your experience, on the type of paper. I don't know. I would say that for a young reviewer, maybe it would be, I think, more than 1 day of work. I would say, at least I remember when I was younger, it's taking, I would say, 2 days, 1 day to really understand, another day to write the review. Then with the experience, you get faster. Should I change the review standard based on the conference and journal? Yes, in the sense that in general, in a conference, the bar is lower than for a journal. And you can check the policy of the journal of the conference, or you can discuss with the guy who invites you to the review. You can also discuss with him by email before submitting the review if you have doubts about this part, and then they will reply in general. So we also got at some point another question that why our publications in robotics, but I think also in many other fields are not double blind. So I don't know if you know what it is. So double blind means that the paper is doesn't have any information about the authors. Okay? The authors are not cited in the papers, and the paper is also written in third person, so you never say we did, we did, but you talk about yourself as if it is another group. Okay? So why our papers are not like this? Because all our papers besides RSS are in the single blind, so the authors are cited explicitly. So I discussed this with a lot of people in the robotics in the RAS, and the conclusion is that, I mean, I agree, I have to say, that double blind is often an illusion, because also with conferences like RSS, I mean, if you start checking the references, you know, you look at the archive for uploads, I mean, at some point you understand who are the authors, and then all this energy is kind of wasted, the energy that they put into making the paper anonymous. Okay? And even worse in robotics, if they are using specific hardware. Yeah? A robot that only exists at one place, then yeah, it's quite clear who are the authors. And also there is another issue, which the author should be, you know, accountable for what they work, what they write. I mean, if the paper is anonymous, there is less of a notion of accountability for the authors. Okay. Now, of course, if the authors are stated explicitly, there can be an issue of, you know, you are scared by the big names, and then but as I said before, you don't have any reason to be scared, because the reviews are anonymous, so you can say whatever you want. They will never know that it is you who wrote the review. So another question that we got is, what about, you know, ChatGPT or generative AI for reviewing papers? So, of course, you cannot use ChatGPT to review a paper. And in the paper, if so there are some guidelines of the IEEE about possible use of generative AI for writing papers, and I suggest you to read them. So anyway, if you use generative AI, you should, including text, figures, images, and codes, every use must be completely disclosed in the paper, and you have to explicitly state, I used a generative AI for doing this, this, and that in the paper. And there are some tools online to check if a paper has been likely written with the help of an AI. Of course, also if you read the paper, sometimes it is quite clear that some parts are, you know, kind of fake. So yeah, I think that the answer here is that if the authors use it, they have to acknowledge it. If they don't, and you suspect that they did, then this is a problem, and you can state it in the review, or if you don't feel like it, you can state it in the confidential comments to the editor. Okay? So how long does the review process take for conferences and journals? So again, it depends. You know, for large conferences like ICRA, it can take from September to January. So it is 5 months, something like that. Because you know, there are many steps, not just reviews, but then there is all the whole program committee who has to decide what papers are accepted or not. For journal, in general, it's a bit shorter to get a review, maybe 3 months. But again, it depends a lot. It depends really a lot on, especially for journals, on the reviewers' unreliability. The reviewers start to be late, everything is late. Can we use language models to train young people to write the reviews? I don't know, maybe yes. Yeah, I don't have an answer. Maybe yes at some points. What you didn't think about when you reviewed the paper for the first time? So I probably, if I try to remember, I think that when I was very young and I was reviewing my first papers, I focused mostly on the math, because that's what I knew most at the time. And I wasn't really able to judge the significance of the work. So I was happy that everything checked out from the math, but then who knows about if the paper was important or not in robotics. And yes, I already talked about this. Yeah, for the conflict of interest. So conflict of interest, every journal and conference has its own policy, but in general, you know, you don't have to be a co-author of some previous paper within a time frame of one of the authors of the paper. You don't have to be a close collaborator or in the same lab, same institution. Anyway, if you have doubts, check with the associate editor. You can always say, I this and that with one of the authors, what should I do? And they will tell you if you are in conflict of interest or not. And yes, and then just this last comment, why the overall process takes so long. Again, it takes long because many times reviewers are late, but also you have to consider that all this work is for free. I don't know if you know this, but reviewers, editors, I don't know if not for the editor-in-chief, but for all the other guys, we all work for free on our free time. So we do what we can. Then you could ask, why then we don't implement a system where people are paid for reviewing? And some journals do, for example, Nature Science, they do it. I think that numbers are very big in our community, and to pay, I don't know, this could be a reason, or maybe it could be done, but they don't want to do it because they want to spend money. I don't know, but numbers are very large in robotics, in AI, in machine learning. So to pay all the reviewers, I don't know if it will be feasible. Yes. So that's all. I don't know if you have any question.
Yeah. A question about the references. So when we review a paper, how deep should we go in the references? Like read at least the abstract of all the references, or just how we understand if they are correct?
And this comes from experience, I would say, because at least in my case, when I look at the references in a paper, if the paper is in my field, I know more or less what are the important papers in that field, so I can judge if they are citing or not the right references. But I don't think that I really go into each reference and check the paper of each reference. It is something that comes with experience, I think, by reading papers, staying in the field, and at some point you know what you should expect. Otherwise you can also look at the year of publication, because sometimes some papers are, they are citing only papers from, 10 years before. So how come that in the last 10 years nobody worked on your topic? And then, so this is also another... Or, for example, something that I also see sometimes is that people cite mostly papers from other communities, not from robotics, for a robotics paper, which is also strange. How come that nobody in robotics is doing so? Yeah, these are something that you can check. Otherwise, it's by experience, I think. Yeah. Yeah.
Just on the software, you talked about checking for plagiarism.
Yeah.
AI generated text. The softwares you noted on the slides are free ones, right? Or do we need license?
I don't know, because I took these stuff from the guidelines of the IEEE. I didn't check them myself, so I don't know. This is what they say, but yeah.
Regarding your expertise with the... sorry, no, go ahead.
It was just a follow-up, do they work on those tools? Because, from what I know of the literature of detection of Gen AI, the false positive rate is through the roof.
Yeah. I don't know. I really don't know. I copy-pasted from... I don't know. I'm sorry. I don't know.
So regarding expertise, you were mentioning sometimes the paper is somehow transdisciplinary and you only know part of the field. Is that still fine then to review and then just state that I only know one or two of the different things that the author are mixing up, and I can only confidently review this little segment of the paper, and the other I can take a look but don't really know that much?
Yeah, I think it is fine, because I will say it is the responsibility of the editor to choose the reviewer. So if you are only confident in one part, I will say check with the editor before. Maybe you can say, look, I only can judge this part. Is that okay? But if he says or she says okay, because it doesn't matter, I will have another reviewer judging the other part, then it's completely okay. I don't see any problem in that. Yeah.
So a suggestion.
Usually with conferences and journals, then it depends on the system, on the platform. After you've submitted your review or after the decision, you can read other people's review of the same paper. And that sometimes it's, at least for me at the start, it was really helpful because maybe I wasn't very experienced. You see, maybe I might have missed this mistake or whatever. It can help you understand more the paper, but also understand how to do a review. What were the aspects that you might have missed? So for the next time, you might improve on that.
Absolutely. Yeah. This for conferences, I don't. But for journals, when the decision arrives, you get so.
For the journals,
For the journals, you get the reviews.
For the conference, you can
check.
okay,
you can check.
You can check.
Okay.
The other reviews after you submitted yours.
Yeah, sure. But for journals, you see the other reviews and you learn a lot about what the other people looked and commented about. Yeah.
Something we have access to when if you're at the Université de Rennes, I just tried it. We have access to a software that is called Compilatio, which is one we used in my previous lab and university, which is a very powerful plagiarism detection tool.
Okay.
Then, at least for plagiarism, it works. Gives you quite a lot of false positives, for example, in the bibliography section, but then you can just say it's the bibliography, don't care about it. And they also have an AI detection, but this I haven't tried. For sure, if you have Université de Rennes account, you can access it. And
okay.
You can try that.
And it's also true that part of the plagiarism check is also done at higher level of the editor, also the editor level. Because before sending papers to the reviewers, associate editors can check with some data already available on the conference platforms, which is the percentage of plagiarism for each document.
And and I learned the other side, you shouldn't fully trust the software. Yeah.
Okay. Anyway, I will make the slides available. So yeah. Okay.
Thank you, Paolo.
Yeah.
Thank you.
Yeah, you're welcome. So now.
So we're now switching to a more specific presentation in the technical talk.
Yeah. I will not get offended.
Again, regarding getting this presentation by Paolo validated by the École Doctorale for the PhD hours for Robustifying. I think it's just put the mail back to me. I will prepare the form, get them all signed at the same time by Paolo. So if you want that presentation by Paolo to count for your mandatory PhD hours, send me a mail. I will prepare the paperwork and then send it back to you afterwards.
Okay.
Thank you. Yes, I'm Leon. I send the first email. Just sending it.
Okay. And you can see also the sharing is working.
Yes.
Okay. No?
No, that one. Wait.
Is it me?
Or is it just from
Maybe you're sharing it on your computer.
What do you mean? It's not doing it anymore.
On the other side, we could just get it.
It says you're sharing your screen. Oh no.
There is the icon there showing that Tommaso is sharing, by the way. It's just that it's not appearing on the screen, maybe.
Yeah.
It should be.
Yes, to me it says you are sharing your screen.
Yeah, I see.
Checking if it's two screens. If you share one screen, then
No, because it was only, and I see, yeah,
The preview.
it's,
okay.
I know it's just mirroring, so shouldn't be.
No, so I have it on my computer, so it's probably just this screen.
No, okay, I go on.
Also working on it.
Okay,
Thank you, Thomas.
so I mean, I guess there is no one left who doesn't know who I am, so I can skip saying who I am. Let's go. So this is an outline of the presentation. This is, I mean, it's going to be kind of like a collection of slides that I've assembled on the topic that I work on with Paolo, which is this sensitivity approach to robustifying control and planning for robots. So I will first give you some background, then some maths about the closed loop sensitivity, how it works, how it's computed, and so on, and then an application to model predictive control. So, which was our the first case in which we applied this to the online planning setting, in which we had an online trajectory optimization, and that it's under review in TRO. So, as you know, very often in robotics, we deal with robot models that we use to describe the evolution of our systems and to control them, to design controllers and planners and so on. But these robot models are somewhat uncertain because they are usually based on principles or on parameters that we might not know necessarily very well, that might be difficult to measure, or that might simply be different from one robot to the other, or could be just the task that changes if we have to pick up some payload and we cannot assume to perfectly know the properties of the payload, its mass, its inertia, and so on. It's just going to be something uncertain. And I mean, it's a huge amount of literature dealing with this. And typically what is done is that the processor actuation noise is introduced in the system, is modeled in a quite generic way. We'll see later, maybe for instance as a Gaussian additive or a multiplicative noise. And this can be fine, of course, if we can't say anything else about it. But in many instances, as the ones I was talking about before, we do know that the uncertainty is somewhere in our system, like in the geometry of the system, the lengths or displacement of reference frames, or in the dynamic quantities. So we can probably do something better than that. And also another aspect to consider is the effect of feedback, since in particular when we are trying to predict what our uncertainty will do in a planning setting, for instance, we should consider the fact that we have a feedback controller that might track some trajectory or might reject these disturbances. So our whole framework should be closed loop, hence the name, which you saw before, as you'll see later. And to give you an example, a classical example in mobile robotics is the one of having a unicycle, where you might have that your uncertain parameters are the wheel parameters, so the radius of the wheel and the distance, the length of the axle. And in like the typical localization setting with like EKF and so on, people put some additive process noise on the dynamics, and maybe some actuation noise, which is just some Gaussian noise. But then how do you choose the covariance of this noise? Like, how big should it be? In practice, you make it big enough so that everything works. Now, a different approach would be to say, okay, actually, my uncertain parameters are this one that enter in the dynamics in this particular way, and to exploit in some way this structure in order to make something better than before. Because, for instance, depending on the system, it might be that your noise enters in the system in some particular directions, in a sense, so it will affect the evolution of the system in a particular way. Of course, there is a huge literature on robust control, but very often you see that even if you want to compare yourself to these methods, they can have a lot of not problems but limitations. For instance, when you deal with adaptive or even just integral actions, you have to take care of the fact that there is additional transient, additional dynamics in your systems, or the fact that in order to do robust control, you might need to find, for instance, a Lyapunov function for your system, which is not always possible or is not always easy. And instead, we went for a slightly different approach in which instead of having a reactive solution to the robustness problem, we try to have a proactive approach in which we do something in order to be more robust, let's say, from the start, from the planning phase. So the general idea is something like this. You have your robot and you have your controller for this robot, which is going to be, let's say, whatever it is. You design it, not necessarily taking into account robustness. And then an idea would be to design the reference trajectory for this controller in order to be less sensitive to the parameters, so that even if these parameters are uncertain, so they change with respect to some nominal parameters that you set, because you think my robot weighs that, my payload weighs that, and so on. And this trajectory will be robust in the sense that the robot will stay possibly closer to it with respect than another different trajectory. And of course, as we will see later, the design of the trajectory and the controller can also be something that is done together, like in the model predictive control case, in which you have the controller predicts and plans the trajectory online and applies the control action to do the trajectory, and still you can robustify that controller and that trajectory. So going a bit more into the maths. So as I was saying, you have your robot that is described by some dynamics, and you have your controller, which is simply, let's say in this case, a function of your state, and you have that the dynamics depends on the true parameters of the system. So the actual evolution of the robot will be a nominal evolution in the case in which the parameters are actually the nominal ones, but it could differ from that one. While the controller might use some parameters of the robot, but only the nominal ones, which are the only ones you know. And we define this quantity, the closed loop state sensitivity, as the derivative of the closed loop solution of the system, the state evolution of the system, with respect to the parameters. So it's a matrix that locally describes how a change in the parameters will produce a change in the state. And of course, I mean, this is just a formula. And the question is, okay, how do you compute this? And the answer is you cannot really compute it in closed form in general, but you can find a rule, a dynamics that describes the evolution of this quantity. And so you will have something like that the state sensitivity at some instant will depend on the state sensitivity at the previous instant, starting from instance from 0, because maybe at the first state of your trajectory, at the first instant, you don't have uncertainty, so your sensitivity is 0, plus some other terms. Now here you have the derivatives of your dynamics, which you can compute if you know the expression of your dynamics with respect to the state, the inputs, and the parameters. And if you just do the chain rule, basically, it also appears another quantity which represents the derivative of the inputs with respect to the parameters. Because again, since you have a controller, if your state changes with respect to the nominal state, also the input that you will apply will change, because the input is a function of the state. And this quantity theta we call the input sensitivity. The input sensitivity you can compute pretty easily and see that it is again a function of the state sensitivity, but also on the Jacobian of your control law. So it depends on your controller, on the choice of your controller. You might have a controller that is more or less sensitive to the parameters with respect to the state. And this quantity is what we call like the feedback gains of the controller, because it's just the Jacobian of the first order expansion of the control law. And this feedback gains, let's say, and this sensitivity is something easy to compute when you have closed form expression of your controller, because you just differentiate, you use whatever tool you want and differentiate. It's a bit less trivial when your controller is the solution of an optimization. And so, but we will see how to do it by differentiating the KKT conditions. Now, a possible use of this sensitivity is the one that I introduced at the beginning, which is to find trajectories that are minimally sensitive to the parameters. So we can use, for instance, the sensitivity or a norm of this matrix in order to minimize the sensitivity at the final time, for instance. If we want to reach a point with maybe our end effector or with a quadrotor, and we want to be very precise while we reach the point, we can find a trajectory that will be minimally sensitive at the end time, and so we will reach the point more precisely. Or we could want to minimize the sensitivity over the whole trajectory. If, for instance, we are doing some trajectory tracking and we care about the performance over the whole time horizon that we consider, or even some combination of the sensitivity, for instance, at the final time, and the input sensitivity over your trajectory, because maybe you care about your precision at the end time, but also you care about the fact that during the motion, your inputs shouldn't change too widely. So the deviation with respect to the nominal input trajectory should stay as small as possible. Another possible use of the sensitivity is to compute tubes. So tubes are a collection of sets that encapsulate the perturbed evolution of the system. Basically, if you assume that your uncertain parameters are in some set, you can map these sets into the state space. And so you will have that, for instance, for ellipsoids, if your parameters, the uncertain parameters, are in some ellipsoidal set, then you can also obtain a collection of ellipsoids over time that will tell you that at each instant your state is inside of that ellipsoid. And I will skip a bit of the math, but essentially to compute this, we do a scaling, but it's more of a technical, let's say, detail. And we use the sensitivity to project these parameters into the state space, this parameter deviation into the state deviation. You can do this, of course, for both the state sensitivity and the input sensitivity, so you can also have input tubes. And what you get is, at one instant, is something like this. So you might have a ball of parameters, all your uncertain parameters are there, and this ball is mapped into an ellipsoid in state space. And this ellipsoid will depend on the state sensitivity at the time. So you can do that for all of the time instants of your trajectory, and you get a tube of ellipsoids. And with this ellipsoid, with these tubes, you can find what we call the radius of the tube, which is basically what is the maximum deviation that I can suffer in one particular direction. Since these are ellipsoids, so they are oriented in some way in the space, you do not have one radius like a sphere, but you can have a radius associated with one direction, which basically tells you what is the distance of the closest tangent plane to this ellipsoid. And you can use this as a kind of collision checking for your system. So if you have some inequality constraints, you might ensure in this way that the inequality constraints are satisfied even if you have deviations. The tubes in general might look like this. So this is an example for a 2D quadrotor. On the left, you have the tubes on the state, like on the position and orientation of the robot. And on the right, you have the input tubes. So you see that while the state is evolving and it's deviating from the nominal trajectory, also your inputs are changing. And if you have input constraints, it might be like in this case that even in the deviation, you are still satisfying the input constraints, so you don't saturate. But if, for instance, these tubes went outside of the constraints, in the perturbed case, it would mean that the system would suffer some kind of saturation that you didn't plan maybe in the nominal case. So it might severely deviate, become infeasible, crash, or whatever in the actual deployment. Because you've changed, then if the parameters have changed, then the input that you will apply to the system, that the controller will decide to do completely autonomously, is going to be different than the one you thought it would be. And it would be something undesired. So, as I was saying, you can use these tubes for instance, in the state and input space, compute the radius of these tubes, and then robustify constraints in your trajectory optimization problem. One case in which we did this is in the paper with Ali and Salvatore, who was a visiting PhD student like me at the time, in which we applied this whole concept to a quadrator, in which we chose as the controller the PIX for autopilot, which is an off-the-shelf controller. It's pretty good. It's very robust. Actually, there's like cascaded PIDs, also integral action. It's estimates the collective thrust on overing, so it even has some adaptation. It's a pretty good controller for quadrators. But the idea was, okay, we can start, for instance, by planning a minimum jerk trajectory, which is a very smooth trajectory. It's a relatively good initial guess for a trajectory. It should be good. It should be robust enough. But maybe we can do better. We can optimize this trajectory to make it safer. For instance, in the case in which we want to pass through some window, and of course, under input constraints. Since in these cases our trajectories were quite aggressive, we had saturations. In particular, we could have saturations while we were perturbing the system by applying some, like adding objects and pliers to perturb the mass, the inertia, and the aerodynamics of the robots. And the optimization problem we solved was this one in which we would minimize the state sensitivity at the time in which we pass through the aperture, which was, let's say, nominal given our trajectory. And we would robustify through the tubes the input constraints, so that in case, so the init is the non-optimized one and the one below is the optimized one. This is one of the 4 inputs. We would have that in the perturbed case, our inputs stayed in the input constraints. Then we tested this repeatedly with different perturbations, and we saw that in fact we were more robust. How much time do I have? Okay, I'll go fast. Okay, so going to MPC. What is MPC? Okay.
You go fast now, then you arrive at the meet.
So MPC basically is online trajectory optimization. You plan a trajectory, optimize a trajectory, and then you only apply the very first part of this trajectory, the very first input. And after a small amount of time, it can be in the milliseconds, you do this again. And you re-optimize again the trajectory over some finite window of time in your future. And again, you apply the first input. So the MPC is cool, but it can fail. It can fail because since you are solving a trajectory optimization problem and you usually have constraints, there are states from which there is no solution, because this trajectory optimization always starts from the current state of the robot. There is the feedback. And this can happen, for instance, if your control horizon, the window of time you consider is too short. You might not be able to see that an obstacle is in front of you enough in advance, and so you might crash, or you might find yourself in a state where there is no avoiding the obstacle. Or it could be that even if your control horizon is super long, you deviate from that planned trajectory, and again you find yourself in a state where there is no solution to the problem. And this happens because MPC uses a nominal model of the system that is going to be different than the one that is actually the one that actually describes the robot. And so we wanted to robustify MPC against these parametric uncertainties by introducing tubes in the constraints. We call this STMPC. And at each instant, essentially, we compute the state sensitivity, or the whole sensitivity of the initial guess of our trajectory. That is actually the solution of the MPC at the previous instant. And we use this sensitivity to compute the tubes that we use to robustify the constraints. But the point here, what makes this not so trivial, is that to do this, you have to compute the input sensitivity to propagate the state sensitivity. But the input sensitivity depends on the feedback gains of the controller. And the controller here is the MPC. And so you have to find the feedback gains of the MPC controller. And this is a bit involved because your MPC controller is, in this case, for instance, a quadratic program that optimizes a trajectory of your system. In this case, for instance, we were using a multiple shooting transcription of the OCP. And this quadratic program is a parametric problem in your current state. So basically, at one instance, everything is defined in a sense, apart from your current state. That comes for your measurement. You use the current state to compute your control action, and you apply the first input. And so this means that you do not have a solution to the problem in advance, but it also means that you can apply the theory of parametric optimization with respect to the current state. So this means that you can actually differentiate the optimal solution of the problem, which is the optimal state and input trajectory, with respect to the current state. And what this means is that you can get the feedback gains of the controller, and also, and these quantities will be needed later, also how the future states and future inputs depend on a variation of the current state. Oh, I skip this. Let's say you solve this system of equations. It's a big matrix that you have to invert, but it's sparse, so you can exploit the sparsity and make it very fast in like 2 milliseconds, and find these feedback gains. Now, all of this is fine, but what we found now is just how a change in the first state of our trajectory affects the first input. So the duk over the xk. But we also want to get, to compute the sensitivity over the whole trajectory, how a change in the second input affects a change in the second state affects the second input. And to do this, basically you can apply again the same principle as before, but what you would get is another big system to invert, which would make everything not very computationally efficient, and you have to do this very, very fast in a few milliseconds. But actually, the cool thing is that we found out that we could rework these formulas a little bit, massage the formulas, and get that this quantity that we want to compute actually depends on quantities that we already have from before, so that we had already computed. So this works pretty well, and it's very fast, and we can do it in real time. Now, to the results, and I conclude. We tested this on two scenarios. One in which we wanted to track an aggressive trajectory, so that our input are very likely to saturate, in particular in the perturbed cases, or also in which we wanted to pass to reach a goal while passing from an aperture, so we would have to avoid colliding with the wall. And here the uncertain parameters were the parameters of the quadrature, so the position of the center of mass, which might not coincide with the geometric center of the robot, which is the one with respect to which we do feedback, and also something like the mass of a payload or a mass of the robot, and that affects the inertia as well. Everything is pretty standard, like cost function is standard, constraints are very standard. Then we apply the input tubes to robustify the input constraints. And so for the trajectory tracking case, first we have a perturbed trajectory without the input tubes, this red one, MPC, in which you see that there is a severe deviation due to the saturation. If you apply the tubes, the input tubes that you see here in blue, instead, we obtain a less deviation, because the saturation essentially is reduced, or the unplanned saturation is reduced. We can do this many, many times for many different perturbations, and essentially see that we are, on average, more precise. Basically, our standard deviation, in the blue case, with respect to not having the tubes, is much, much less, and so we are more performant. We also tested this, on the real robot with a payload that we placed on the robot in different places below the robot, attached to the legs, and repeated the experiment many times, and saw that in fact we were more precise. But maybe more importantly, and I skip a little bit farther. This is a case for an even more aggressive trajectory here in the Métivier room. More importantly, what you see is that in some cases, the perturbation might, if you don't have the tubes, the perturbations might make you crash. And this is done with the same perturbation. This was done before than the other. Instead, with the tubes, you do not crash because you do not enter in this oscillation that eventually makes you unstable. Now, for the position constraint, instead, you can see that if you do not use the tubes, you might collide. So it becomes unfeasible, there is no solution, eventually you collide. While using the tubes, you're able to pass through the aperture. And again, if you do this statistically for many perturbations, you see that the success rate is much higher using the tubes, so in the case in the left. And very last slide, so there could be a question like, okay, forget about the tubes. Can you make MPC more robust without doing all the stuff with the KKT condition and so on? Because one might say, okay, you increase your control horizon. That should make you more robust. That should make you safer because you see, this is in the second scenario, so in the aperture case, you see the obstacle more in advance, you can do better. Or you could increase the velocity cost in the cost function so that basically your trajectories are slower. You move slower, so you're less affected by these uncertainties and you have more time to react. Well, the answer is essentially not really, because you can do this, and it does affect a little bit the success rates in general, but you do not get to the level that you get if you use the tubes. And for instance, in the case of increasing the control horizon, this has a computational cost, so which is not negligible. So in a sense, what you are doing in this case, while still better than this one, it is also more computationally efficient, all things considered. And I conclude, if you have any question.
Yeah. Just a question on the last video you showed with the sensitivity aware NPC.
This one?
There's, this one. There's still like a big deviation at the end for some trajectories. How can you explain that?
Because the point is that here, the controller is just doing the proactive robustness. So it's not doing something necessarily to counteract the deviation. So it is not tracking a particular trajectory, it's just regulating to that position. And it doesn't know the actual parameters. And the parameters are not being estimated. There is no adaptation in the controller. It's kind of, so I would say that there are two orthogonal problems. Like you might also want to add some adaptation to this controller. It's something that we're starting to work on in order to also recover from this kind of deviations. Like you are more precise essentially because you can also reach at some point maybe the same level of accuracy if you knew the actual parameters, the true parameters. But here we are doing something orthogonal because we are not estimating the parameters. We are making what we do less susceptible to those parameters, to those uncertainties. And so it is expected in a sense. In this case, for instance, there is always going to be an offset in the end, because if your mass is uncertain and the controller, it's not an adaptive controller, you do not have integral action, so constant disturbances are not rejected. That's normal with any MPC like this, basically. It happens in both cases.
At the beginning, I'm not very familiar with the MPCs.
Yeah. It's like if you use PD instead of using PID, you would expect this.
You will have
an offset. Yeah, an offset. Exactly. And this is what happens here. Yeah. But let's say that in this case, what you care about is not colliding and is not necessarily being precise.
Okay. Thank you.
Okay.
Just a last minute, but I just have a question on animation. That okay, since you are more care about to not collide instead of following exactly the trajectory, is the same strategy that they use for example, for racing in drones? You know that?
What, or in which sense is the same strategy?
Just to prioritize do not collide with the obstacles instead of falling exactly.
Yeah, well, I mean, here you do not, in this case, you do not have a reference trajectory that you want to follow, which I would say, yeah, probably in drone racing, that's, they don't really, I mean, they do drone racing also with like NPC, and they, I mean, yes, the thing is, it depends like what you want to solve, because in any case, you would have, even if you had a trajectory to follow, then you would still have to consider the obstacle avoidance. Like you cannot just say, I plan a trajectory that does not collide, and I track the trajectory without forgetting that there is an obstacle, because you will deviate from that trajectory. And I mean, even if here there was a trajectory to follow, this would deviate from the trajectory, and so you would collide. So it doesn't change really much in a sense. And even if you had a trajectory to follow, you would deviate from that trajectory, which in fact is what happens in the previous cases. Like here. Yeah. Like you see, you deviate from the trajectory. So if there was some obstacle, it would crash. Thanks.
Thank you, Thomas.
Yeah.